welcome to the latest soldering tutorial. Thank you for tuning in. Now, some of you have seen some of my other videos on my channel. You've probably seen me do quite a bit of surface mount work and yeah, some few sort of tricky repairs. But this particular video I'm going right back to the basics to hopefully aid a few newcomers. So we're going to talk about a few about soldering irons, a couple of different products that might sort of aid beginners on their journey, and yeah, hopefully sort of find it useful along the way. Now, the first part of the video, I'm going to talk about different solders, different soldering irons. So we'll start with the solders. Now, down the bottom, we've got 4 different sizes, ranging from a 0.25 all the way up to a 0.9mm. But if I was starting out in the soldering world, I'd go for about a 0.5mm. That's going to do most of your work. That's the size that a lot of people sort of use for general soldering. So go for 0.5, should be alright. 0.25 is mainly for doing sort of fine pitch surface mount, which you won't be doing in the early days, so there's no need to get that. Now, solder comes in sort of 2 different varieties. You get lead free and leaded. Now, leaded solder, I'd get my iron set to about 330 degrees centigrade, lead free about 350 to 370 degrees centigrade. And yeah, so, and also with the solder there's a built-in flux running through the middle, but you can get external flux if sort of required. And I do use quite a lot of that because I find flux in the solder can burn off a little bit quick. Now, solder's got quite a few fumes in it, so if you can get some kind of extraction, that's a good thing. So you go for a 0.5, should be alright. Now, with the soldering irons, the one at the top of your screen is a Weller TCPS. That's the iron I use the most. That's my favourite iron. You get a lot of different varieties of tips, but these are the 2 I mainly use. Got a small conical and a large flat sided, and they do most of the work for me. Now, that iron plugs into a base unit and that retails for about £200. But if I was starting off in the soldering world, I'd just go to my local hardware store, about £25, pick up one that plugs straight into the mains. You might only get 1 or 2 different size sort of tips for the cheap irons, but yeah, probably it'll get you sort of learning the sort of basics of soldering. That's plenty good enough to start off, and as you go through sort of your journey, you can sort of up the type of iron you've got. Now, the one in the middle is a Metcal. As you can see, it's tiny, about the size of my tweezers. This retails about £800. And as you can see, you've got the tips on it are tiny. They're only literally that one there, sort of size of the end of my tweezers. But that's basically for advanced surface mount work, so you won't need anything like that when you're starting out. The 3 tips above it, just different size Metcal tips for another type of Metcal iron. Like I say, go for a cheap one from your local hardware store, £25. That's good enough, and yeah, 0.5mm solder to go with it, and that's what I'd recommend. So what we're going to do now, I'm going to move on to a useful PCB jig. I'll do a couple of demonstrations with that. It's something you might sort of aid you if you're starting out, and yeah, move on to that now, and yeah, hopefully you find that enjoyable as well. Following on from the discussion we just had about solders and soldering irons, we come on to this PCB jig. Now, it's a fully adjustable, all types of ways. It's great for holding your boards or your wires if you need sort of a third hand. Like I say, it's adjustable up and down, so whatever you need. Jaws open up different widths. It's adjustable, yeah, sort of got ball joints on the end, so you can go whatever way you want with it. It's a great item, and I've used it quite a lot over the years. I'm going to do a couple of demonstrations after this short video, sort of what it can be used for. Like I say, it's a great item to purchase. It's available from sort of Farnell RS Components in the UK, or Mauser or DigiKey in sort of America. Like I say, you will get good use out of this, so well worth thinking about. So what I'm going to do on one of these demonstrations, I'm just going to solder a wire into the board to show you sort of how easy it is. And that particular solder method is going to be a sort of preloaded iron solder joint. But later on, I'm going to do some variboard soldering, and I'll show you the method where we feed the solder into the joints as we go. So what I'll do, I'll move on to the demonstrations now, and yeah, hopefully you see the use of yeah, how good this jig can be. So we'll move on to them now. To the first demonstration of the jig that I've just spoke about. Just going to show you how you can neatly sort of solder these 2 wires together using the jig as an aid that will hold them in place while you're doing the process. First thing I do, just strip me wires about 10mm off each end. I'll do the second wire now. So I use a trigger style sort of stripping tool, And there's many different wire strippers on the market. This is just the one I prefer for this sort of type of operation. Now you could push the wires together now and twist them as a pair, but for this this demonstration I'm just going to do a simple lay joint. So we get these sort of tinned up first. Now I'm just going to add some external flux, just run sort of slight bit of flux along the joint, and we'll get them tinned up now. And when you're doing soldering, the fumes can be quite poisonous, so if you've got an extractor, that's a sort of good thing to use. You will get quite a few fumes when you use flux in soldering. They've got them neatly tinned up. Now this is a time you don't want to forget your sleeving now. If you've got sort of, if these 2 points at the ends were going into our external sources and you've soldered that up, you wouldn't be able to get your heat shrink on. So what you want to do now, just lay them next to each other. So you can sort of twist these together as a pair at the start, but this is a simple lay joint, quite a common method that a lot of people would use. So I'm just going to zoom in so you can see the joint go better. So again, just run a fillet of solder over the top of the joint. So as you can see, you've got a nice joint right along. So yeah, what you want to do now, push your heat shrink on. I'll take it out, it's probably about 2 or 3 millimeters at each end. And we'll get this this shrunk down. Just turn that round slightly so you can see the shrink go better. So I've got my heat gun set to about 170 degrees. Now if you haven't got a heat gun, just going to move it this way, sorry. If you haven't got a heat gun, you can use some people run their soldering iron along it, or even a lighter. I've seen people do it with a lighter. But obviously you've got a hot air gun, it's yeah, it makes the job sort of easier. Like I say, I've got this hot gun set to about 170, which is the temperature I like to do for heat shrink. You can get glue lined heat shrink. This is just simple sort of heat shrink, but the glue lined stuff gives a really sort of strong joint. So that's nicely shrunk down right along the whole joint. As you can see, we've ended up with quite a neat job. So I've got a well protected joint, sleeved out at both ends, and the jig's done its sort of purpose in holding it in place for you. So yeah, that's the first demonstration, and what we're going to do now, I'm going to move on to some PCB sort of work. I'll hold that in there and you can see the benefits of the jig using that. So following on from the 2 wires that I sort of soldered together in the jig, I'm now going to show you, this is where it can be useful if you're soldering say a wire into your board. Yeah, using the jig as well to hold it in the air. You can do this on the bench, but when you're doing this particular type of job, it's a lot easier basically if you've got a little jig like this. So yeah, what I've done, I've already pre-tinned and sort of pre-cut the wire just to speed the video up. I've done it exactly how I did before. What you're going to look for on this, when you put the wire through the hole, you want about 1 millimeter. Yeah, about 1 millimeter to 1.5 from the board to the top of your joint. That's the desired sort of length in the soldering world. So I've already sort of pre-cut it, like I say, just for the sort of to aid the video. Now I'm just going to add some external flux, because like I say, it's already in the solder, but this will aid your joint getting some external flux. So what I'll do then, I'll sort of preload my iron with some solder, and yeah, we sort of get the joint sort of soldered up. Basically what you want to do, so I've got about a nice joint there. I'll just zoom in slightly so you can get a better view. I've got a nice sort of cone shape along the around the joint. As you can see, it's not overloaded with solder. You can still see the wire coming through. So you want, if you can get about 1 millimeter to 1.5 to the top of the joint, that's what you're pretty much looking for. And yeah, that's a nice joint. And yeah, basically with the barrel, you can see that goes through the board. If you take the hole next to it, you've got the sort of barrel going through the one top to the bottom layer. What you're looking for really on an ideal joint is to sort of fill that barrel up, or at least 75% of the way through. That's the sort of standard soldering that we go for. Yeah, right the way through, or sort of 3/4 of the way through. and that's what you're looking for. So this is when the jig's sort of useful, just to hold sort of items like this. And yeah, and it's so it's a good aid. I definitely recommend getting one, and yeah, basically it will come in useful at times for you. So what I'll do now, I'm going to put a couple of photos up what we've done so far, and then yeah, move on to the next stage after that, and hopefully you find that useful as well. First, this is basically what I use to clean my tips during sort of my soldering processes. Basically, yeah, as you can see, I've got some solder on the tip, and there's two methods really for this. You've got your wire wool method that I'll just bring in. I normally sort of dab it, and that basically, if you dab it in the pad, that will basically get your tip nice and clean. You'll get all the solder off. Normally I'd have this on my stand, so I'd just enter the tip into the wire wool, but for this video I've just brought the wool into the tip. So yeah, that's one thing you can get, a wire wool pad, or a lot of people use a damp sponge, which is probably my preference. Now what I also do, when I finish my soldering, if you're not going to solder for a little while, your tip can oxidise and it can be quite difficult to get it to start again next time. The best thing to do, real quick tip, if you just add a nice lump of solder and leave that laying on your tip, and let your tip go cold like that. So next time you come along, you can just wipe that off, and you'll have a nice sort of nice clean tinned tip ready to go next time. So yeah, hopefully that helped you, them sort of two little bits. So yeah, leave a little bit of solder on your tip if you're not going to leave it, use it for a while, and you should be good to go next time. So move on to the part of the video now. I'm just going to show you some basic component fitting into this Vero board. Now Vero boards are very good sort of common material. It's good for sort of practicing your soldering. You can also make mini circuits out of it, but with this particular one I've got tracks running right along it. You can get a Vero board that every sort of hole's separately individual from the next one. With this one you can actually separate the pads by what I've done up the top corner. I'm just going to zoom into that so you can sort of see it better. Yeah, so up that top corner I've got a fair few holes that I've separated. Now there's a special tool for this, but you don't really need it. All you do is get any sort of common drill, just go, yeah, just basically about a quarter of the way down, and you'll take the copper away around the hole, and then you've sort of separated the other pads. So yeah, this is quite a good sort of board as well. But like I say, if you want the individual ones, you can get them. They're pretty common and easy to get. So yeah, basically that's how I'd separate the holes. And what I'm going to do, I'm going to show you a few different ways to fit some resistors, some through hole components. And yeah, I've got 3 different ways I can fit them. Yeah, depending on the footprint of your board. So I'll show you them as we go through, and I'll show you a couple of different ways to do your joints, and hopefully yeah, you might sort of learn something along the way. So I'm just going to start, I'll just move on to fitting resistors, and we'll show you how we do that. To move on to fitting of the resistors into the Vero board, the through hole resistors. Now, what a lot of people do to form this component, sort of to get the to get it to fit, basically a lot of people just get hold of the body, bend it roughly like that. You end up with not a great sort of looking component. You're never guaranteed the legs are actually going to fit the holes that you require them to. So it's not what I'd recommend. I'd always recommend sort of using pliers and sort of forming it properly. Yeah, any cheap pair of sort of small pliers, and you can sort of get a nice bend like that. And that's going to guarantee I can fit that between the holes, because you can sort of pre-measure it before you sort of start work, and that's what I'd always do, that sort of method, and that will fit between the holes that I require. So there's also 2 other ways you can fit through hole resistors. Now if you've got footprint issues where you haven't quite got the width that you sort of need, this is quite a good way. Literally pop it into the board, just blow that sort of up slightly. As you can see, I didn't have the width on this, so you can actually sort of stand it up in the air. This will work perfectly well. So if you've got width restrictions between holes, this is quite a good method. And yeah, it's one I've used a fair bit over the years. It works, like I say, it worked perfectly well. So that's one option. There's also another option. I'll just sort of put this one in front of it. Just pop it in the holes. So if you're restricted, again, because the legs are coming under the body on this one, so if you're restricted on width between the holes, the space between the holes, this is another option. Resistor's slightly up in the air, as you can see, but it's going to work perfectly well. And so together with a properly fitted one, the first one that I showed, these are the other two options to so you've always got an option, sort of no matter what size you've got or what distance you've got between the holes. So what I'll do now, I'm going to move on to the underneath of the board, and I'll start showing you. There's two different methods basically for soldering them up. I'll sort of move on to them, and we'll get to see them, and hopefully you sort of find them useful. Right, so as you can see, I've got two resistors that I've put through the board. Now the common method that a lot of people do, it's not what I like to do, but a lot of people do, it's fine, this method. Here we do is bend them two over. Now it's not a bad method because it does keep the components sort of down onto the board, and then you can just trim the legs off. And that's perfectly gonna, that's all you're looking for, as long as the legs don't go beyond the sort of hole that I've sort of drilled out and onto the other pad. That's fine. So what I do, so that's going to grip that component. It's quite a good method, but it's not what I like the sort of straight up method. You can just generally use your side cutters. Just get them up the right way, that'll help. And just literally just snip the leg off about 1.5 millimeters high. And then what I normally do when I do this method, the other method's quite good because you don't have to sort of hold the component in place. If I'm doing this method, I'll literally just tack that into position, and then I'll solder it up properly in a minute. So tacking it into position just means putting a small amount of solder on it, and that's going to grip that component, and basically you can then solder it up properly. So what I'm going to do, I'm going to change the camera angle now and get a right close up. We get a right close up view of the soldering taking place on both these methods. So I'll move on to that now. So coming on to the first two joints, these are the ones basically that I sort of bent over and trimmed down. Now, like I say, with all my soldering, you don't always need it, but I always find it's good to add just a little bit of external flux. So there is flux built into the solder. I always like to add if I can, some external flux just to aid the joint. And what I do, I always put a tiny bit on my tip just to pre-tin the tip. And just feed it in and just just get a nice amount. Just cover the pad, and same up the other end. That's what you're looking for. I'll just fill that hole up there actually. So as you can see, I've got a nice sort of fillet going around the joint. The hole that I had basically filled in now. If you've got a leg and it's sort of quite a bit smaller than the hole, you might get what I had there, the sort of hole around the back. Just fill it up basically. As you can see, that one's fine. You can just about see the outline of the leg coming out the solder. That's a nice amount of solder on there. It's good if you can see the outline. Basically you've got a good joint if it looks like that. And that's what I'm looking for on them two. So what I'm going to do, I'm going to sort of go to the back two, and basically they're the ones that I sort of trimmed up straight, and just tacked one in position. So I'll do this one first and try to get the focus slightly better. So I say, as you can see, the leg's quite a bit smaller than the hole on these. Because Vero board has no barrels, sometimes you will get sort of gaps around your leg. So if you can just fill it in, that's a good thing. So again, just feed me solder in. And I've got a nice amount. You still see the top of the joint, and that's what you're looking for there. So I'll just go to the one that I tacked in earlier. And just do that one the same basically. So if you get a hole around it, it's not a problem. You can always revisit it. And again, as you can see, I've got a nice sort of amount. You can see the top of the leg. So that's about 1 to 1.5 millimeters high, and that's what you're looking for. And so that's the two methods. You've got the two straight up ones or the two bent over ones at the front. And they're the two methods that people will use. So basically put your iron on your joint, feed your solder in, and you can't go far wrong. That's the way that I like to do it, and I think most people would probably prefer that way. So so basically that's the way I fit my resistors, that's the way I solder them up. And yeah, hopefully you found the video useful. I'm going to sort of finish it there. There's a few other tools that you can get that you sort of may need along the way, sort of solder braid or solder wick as it might be known. Yeah, get yourself some sort of runny flux, sort of widely available. All these sort of things that I've spoke about in the video, sort of Farnell, sort of RS components, Mauser, DigiKey if in America. There's other sort of retailers online, and yeah, get yourself the sort of main 5 items. Get yourself a nice pair of cutters, pair of tweezers, yeah, some basic couple of different size solders, a decentish soldering iron, but like I said earlier, if you get a £25 one, that's going to sort of get you started. So yeah, I hope you've enjoyed the video, and hopefully you've learned a few things along the way. What I'll do, I'm going to put a few more pictures up sort of at the end, and yeah, hopefully I'll see you again soon, and thank you for your time, and yeah, good luck with all your soldering projects. So I'll see you soon. Thank you.